So let's start. What is probability? Probability is a branch of math that deals with the likelihood of something happening. It calculates the likelihood of something happening. What is the chance that something will occur? What is the chance that given event will occur? And being a math student, we express this chance by a number between 0 and 1. We express this probability by a number between 0 and 1. If the probability of something happening is 0, then such an event is called an impossible event. That event will never occur. And if the probability of something happening is equal to 1, it means that event will definitely take place, right? So the probability is the likelihood, is a chance of something happening. What is the chance that an event will occur? You use this word or this idea even in everyday life. When you wake up early in the morning, you look at your cell phone and you try to see the weather, right? And you see, let's say your cell phone says today is a 90% chance that it will rain. So this 90% chance, it's very close to 1. So you think the better to have an umbrella, right? So you always use this word in everyday life. Even you're talking to your friend and you say probably you are right. When you use this word probably you're right, it means you are showing certain level of uncertainty, right? And this uncertainty is inherent in inferential method. And before we start the inferential statistics, it's essential that we see these ideas, right? So remember, so probability is we quantify the chance of that thing happening. We quantify what is the chance that event will take place, and we express this by a number between 0 and 1. Remember, if the probability of something happening is very close to 0, it doesn't mean that it won't take place. And again, if the probability of something happening is very close to 1, it doesn't mean it will definitely take place. So this is important thing to understand. Very brief history. Mathematicians used this probability, the idea of the probability, way back in 17th century. And in France, the idea was started, and the basic purpose at that time, it was used for the various gambling strategies. So the concept started, the study started in not in academics but in this gaming strategy, right? So before we go further, we need to understand the basic terms we use in probability. Let's see what are the basic terms. It's a very important slide in this chapter. You need to understand the basic term. Without basic understanding of these things, you will struggle. So let's see. The first thing you need to understand, what is an experiment or a procedure? In statistics, an experiment is any activity. A procedure and experiment is any activity with an observable result. You perform any activity and you observe the result of that activity, then such an activity is called an experiment or a procedure. For example, you flip a coin and you note whether the coin lands on heads or tail. You roll a die and you see what number comes up, or you pick a card from the deck of a well shuffled card. These are the examples of an experiment. So an experiment is any activity in which you take measurement or you make an observation. What is a trial? It's a repetition of an experiment. Let's say I flip a coin one time, I flip the coin second time, I flip the coin third time. I am performing different trials of the same experiment. So a trial is a repetition of an experiment. What is an outcome? It's a result of each trial. Let's say I flip a coin. So the results may be heads or tail. So these are the two outcome of my experiment. So these are called these are the results of my trial. These are called outcomes. What is an event? An event is a collection of outcomes. First of all, remember this word event is used differently in statistics as we use this word in English. in English, when we say an event, we usually mean a life event. You are getting married, or you're graduating a class. So you have some major event, right? So, but in statistics, we use this word differently. What is an event? It's a collection of outcome. Let's say we have an experiment. Let's say we roll a die. We roll a die, right? So these are all possible outcome. When I roll a die, these are all possible outcome. Let's define an event like this. I have an outcome 2, 4, and 6. These are all outcomes in which the number showing up an even number. So this is, I'm defining this event as, let's say, with the uppercase letter A. A is an event, and the event is getting an even number. Getting an even number. So this is an event. Now note that this event consists of, it's a collection of outcome. 2, 4, 6. I have combined certain outcome, and such a collection of outcome is called an event. Right? What is a simple event? An event describes a single characteristic. For example, a day in January from all the day in 2015. So note that this event is described by a single characteristic. I'm talking about all those days which fall in the month of January. To have a single property, just single characteristic I'm showing. Such an event is called a simple event. What is a sample space? Very important concept to understand. A sample space is a collection of all possible outcome. All possible outcome. Such a collection of all possible outcome is called a sample space. I will give you an example and then you will understand better. For example, let's say we flip a coin one time and the question is asked, find what is the sample space in these two cases, right? We flip a coin one time and we are asked to find out the sample space. Let's see what is the sample space. We represent a sample space by a letter. So we want to see what is the sample space when we flip a coin one time. We represent a sample space by letter capital S, and this is always given by. So when you flip a coin, what are the outcome? We get heads, or we get a tail. We get a tail. So these are all possible outcome when I flip a coin one time. Okay. Now we want to see what is the sample space when I flip a coin two times. So let's represent this by a letter S. This set, we represent this set by S. So this is heads, tail, heads, tail, or tail, heads. These are all possible outcome when I flip a coin two times. So this set is called a sample space. It's very important that you understand this concept. It's very important for the future evaluation of the probability. Let's see what we have. Now we see how to compute the probability. But before we learn how to compute the probability, it's very important that we understand some of the notation. Okay, the first notation. First of all, in this entire chapter, we represent the probability by uppercase letter P, and the events, and we represent the events by uppercase letter like uppercase A, uppercase B, uppercase C. So we have a reserve letter for probability, uppercase P, capital P, and we use the uppercase letter of English alphabets A, B, and C for the event. So what PA stands for? PA stands for the probability of an event A. This notation, you need to understand this notation. What PA mean? We use this P for probability and this A for an event. So this is read as the probability of an event A. Now, What are equally likely events? What are equally likely events, right? It's clear from the name. Clear from the name. Two or more events are said to be equally likely if each one of them have an equal chance of happening. For example, if I flip a coin, then the coin can land on heads or it can land on tail. Both have an equal chance of happening. Such events are called equally likely event. Now we see a rule to how to compute a probability. This is the thing we were preparing for, right? The F over N rule, right? What this rule says, if you want to find out the probability of an event, you take a F, which is the number of ways an event can occur, and you divide it by the total number of all possible outcomes. Let me write this in another way so that to make it more interesting. So the probability, if you want to find out the probability of an event A, what you do, you always write a fraction. You always write a fraction. On the top, you write number of ways an event can occur, and you divide this by total number of number of possible outcomes. Right? So this is the basic definition of the probability. Basic definition of the probability. Very, very important definition. And most of the time, majority of the time when we will be computing the probability, this is what we will be using, right? Sometimes some people also use a very simple version of the same definition. They say, oh, we use this version. The probability of an event A is equal to what you want divided by what is total. An easier version of the same thing. The easier version of the same thing. Some people say, oh, this is more, you're making this more tough. This is the easier version. But both are the same thing. What you want, you write at the top, and what is the total, you write at the bottom. So this fraction will give you the probability. So these are the basic terms. You need to understand this. I hope you understand this, right? In the next video, I will show you how to actually compute the probability. Thanks for watching.